me 1 second on that. I'm not sure if I can do that from here. Let me check. No. Let me get in touch with Aja and see if she can. Yeah.
Okay. Let me get my. Okay. Oops. Do I have that right? No, I don't think I have that right.
Oh.
Okay, that doesn't look right. Let me fix this real quick.
Okay.
Okay,
Do
it's
you have
giving
a
me.
trampoline in the background? Is that the noise? Is that the sound?
Yeah, it's my neighbor's house. Let me move.
Oh, no worries. You're fine. My daughter definitely loves the trampoline, so I know that sound.
Okay, let's. There we go.
Okay, perfect.
Can you guys see my screen?
Yep, that looks great.
Okay. So my name is Brandon Foster, and I did my research paper on data mining and cyber forensics with AI Assist. So the agenda for what I've got, and then this is just a little example of how data mining works, taking your databases, your data sources, processing the raw data, and either storing it in a data warehouse or you analyze it or have it analyzed, and then you can format your data. Then it goes to the person, the data scientist. So that'll be where it's reviewed, and it can either be refined at that point and it'll go back through the analysis, or you can make your report on your findings and interpret the results and take the actions based on your results. And in cyber forensics or digital forensics, generally your report outs and interpreting your findings, you're looking for data that's not really supposed to be there. So this presentation is going to be a visual and verbal representation of my research paper. Data mining is a study that is used to help investigators close cases that are either being committed or have been committed where certain data may not have been available. In digital forensics, data mining is used to gather and parse data, hopefully leading to the arrest or conviction of a criminal that has committed a crime that they tried to hide by destroying data or information, but did not totally get rid of that data. I mean, that could be anything up to them smashing or burning their hard drive, things like that. A little bit of background. The reason I chose this topic is I'm kind of a nerd when it comes to my TV watching, and I've always thought like watching Criminal Minds, what Penelope does, and Abby, and watching Mr. Robot, things like that. The data mining aspect of it and trying to solve crimes, things like that, really interest me. So, uh, my problem statement: want to explore the current state of data mining, with the pros and cons. And on here, you can see I got a few: identifying security holes and blind spots, detecting zero-day attacks, identify complex and hidden attack patterns, and gain valuable insight from pre-existing data. And some of the cons. Right now, cyber forensics, you really have to have specialized knowledge in data science. It's not for everyone. Requires a lot of time and effort to prepare the algorithms and upkeep on your platforms that you may be using, your applications, things of that nature. Uh, you're constantly updating your classifiers and your mining techniques. And you do run the risk. One of the cons that I was looking at was you may leak confidential information in your data mine, because once you start a data mine, that information is out there, and if someone's listening on the line or decides to hack in while you're in the middle of it, they're going to be able to get the information that you're looking at. Background information: data mining has been around for a long time and is the study of large amounts of data that has to be parsed and verified in order to create a digital footprint of possible crimes. Digital forensics goes hand in hand with data mining, as the forensic side is the study of information that has been parsed by data mining and gives the police a path to follow that data to an endpoint. It contributes to the verification of that data. Cyber crimes have been on the rise since the internet has come around, and is the act of stealing data or information from unsuspecting people or businesses. This includes denial of service attacks, malware, Trojan horses, viruses, keyloggers, and those are just a few things that hackers like to use to capture information that is generally not available to them. In the related works section, both of these came from the same author, and he talks about on the Internet of Things and the way we as people are today generate a lot of data from our online interactions with businesses, government agencies, and educational institutions. The data is referred to as big data, which are data sets that are too big for humans to analyze. Instead, a computer does it for us. Data mining turns that raw data into useful information that helps businesses answer critical questions about their uses for their customers. In order to create marketing campaigns that appeal to particular customers and ultimately increase bookings, like a travel company, or for a travel company, they would set up a cross-functional team that's comprised of data scientists, IT specialists, marketing managers, and they would do a data mine and see what people are looking at, where they want to travel, things like that, and they would build um, specific specific ads for those people. That you go on Facebook, it'll pop up like, "Hey, we saw you looking at going to Fiji. Here's a trip to Fiji." Things like that. The approach for this is the association rule, which is finding your correlations between items in a data set, classifications, which is sorting the data into the categories based on their attributes. If clustering, which is getting all your data grouped into small clusters based on the similarity or distances um, of what you're looking for. Regression is finding a function that fits best for the data and predicts future values. Sequential patterns, finding frequent or rare sequences of events in a data set. So in terms of digital forensics, if you have a lot of stuff on a hard drive and you have your algorithm set and it spits out, okay, you have these 10,000 files that all kind of match your algorithm, so those are safe, but you have this small group of 75 files that are outside of your algorithm, that lets you know what you need to take a look more in depth at. You can either resequence your algorithm to incorporate different aspects of the data to see if that changes it, or uh, if you're a digital or a data scientist, you can actually look at that data and go, oh, okay, that shows right there that they had a search on Google for how to commit the perfect murder or other unspeakable type acts that are very big nowadays. Your decision trees, creating a tree-like structure that splits the data based on your rules and criteria. That kind of goes hand in hand with your sequential patterns. Outlier analysis, that is again with your sequential patterns, that lets you know what the abnormal, normal, or unusual data points are that deviate from your frequent patterns. And then neural network, creating a network of nodes that mimic the human brain and learn from the data. So that's where the AI comes in. It's a machine learning. So having that AI there to learn what you're looking for, so that it can run it itself at a later time, or continue to run it after you're done. Data collection and data collection is the collection and dissemination of data, and that is the whole point of a data mine. Data mining in AI extracts valuable patterns and knowledge from larger data sets. Real life examples demonstrate its application in predictive maintenance, customer segmentation, fraud detection, drug discovery, and things like that. Use cases can help with e-commerce, healthcare analytics, stock market analysis, social media insights, like I talked about earlier with the ads. And hey, we saw you want to go on a trip to Fiji. Again, looking at someone's hard drive or someone's internet activity can say, hey, they were searching how to commit murder, or they were searching for how to use succinylcholine to make someone incapacitated, things like that.
Hey, Brandon, I'm just going to mention that we're getting close to our time limit. So
Okay.
we got about 3 more minutes. So.
Okay. So on this next slide, this is just kind of a couple of the 2 different forensic toolkits that they have out there, or one's called Autopsy, one's called Forensic Toolkit, and they allow you to run your data mines, and they can parse the data for you and put them into different folders. Data analysis, obviously using AI to disseminate the results, will allow you to process data and information much faster. So it allows you to do bigger data even faster, so that you can close more cases or help with more cases from a forensic standpoint. Here's the findings. So your findings will be spit out. You can have different types of graphs and things like that. This one was the one I found, and it just shows it on like a dot graph, so you can see in iteration 0 and iteration 1, you have 2 big clusters, and then you have some data on the outside, kind of like what I was talking about. The convergence, they took iteration 1 and 2, combined them, and these are the red dots are the ones that you're going to want to take a bigger look at. And then in conclusion, data mining in the cyber forensics field of study has grown and will continue to grow. Data mining is used in nearly all forensics cases nowadays to gather data, since we are in the age of the Internet of Things and everybody has phones, computers, tablets, all of that. So that's a growing field, and people don't realize that they're leaving breadcrumbs because they don't really pay much attention to what they're saving on their phones. I had a demo video of JMP, which is another data mine type of deal, but I showed you the screenshots from the other one, so I'll go ahead and skip that. I did leave my literary review on here, and my resources. Does anyone have any questions?
Yeah, that was super cool. There's like a lot of stuff that you covered there. When you're typically looking for you know, doing forensics, is it kind of piecing together incomplete files? Is that sort of one of the use cases that you're focused on?
That I would say that's kind of a big part of it. But more or less like when you have data that someone has tried to delete off of a hard drive, right? And again, like you said, incomplete. Or they did the delete, but they didn't completely delete it off the hard drive. They just deleted the file. So yeah, trying to find that information within the hard drive or within their phone or whatever it may be, and bring that back so you can actually view that data. So
Okay, cool.
it's like
Cool.
fixing
That was super
puzzles.
cool. Yeah. Cool. That was awesome.
Any other questions?
All right, Joey, do you want to do your presentation next?
Sounds good.
Cool.
So let me go ahead and set it all up.
All right.
Alrighty, can you see my screen?
Okay, looks great.
Perfect. All right, so my project is about creating a resume builder to help job seekers create a tailored resume for each job application. So we have the agenda. We'll cover each of these points and talk about the problem I was seeking to address, to the findings, and any relevant future work that would increase the value of the project, and then we'll do the Q&A. So more and more recruiters are using AI parsers to analyze applicants' resumes based off their resume or off their relevance to the job description. Any resumes that fall below a certain score aren't even considered or viewed by the recruiter due to the factors like skill relevance, resume length, fluff, etc. Since most people, especially job hoppers like me, will use the same resume for multiple application, this lowers the chances of moving on to the next step. So by creating an automated program to create the tailored resumes, I'm hoping to increase the job seeker's chance of moving to the next hiring step, as well as save them time on the job hunting process. So here we see some results of a study of resumes. As you can see, almost 90% of resumes don't match the recruiters or the AI's criteria, and many job seekers fail to list enough keywords and soft skills, or they add too much irrelevant information. So with the increased use of AI in the hiring process, I feel that the job seekers haven't been given the same tools that the businesses use. Resume templates have been available for many years, but there's minimal guidance on what information should or shouldn't be included. And the oversaturation of these resume templates makes it pretty impossible to tell if the template you're using is properly formatted or would be accepted by an AI parser. Since these parsers have become so prevalent in the recruiter side, I wanted to create a similar program that assists job seekers instead. So here's the related work section. As you can see, the key topics include natural language processing to identify and extract keywords in a given job description. We also use NoSQL database creation with JSON to store the user data on their skills and experience, and then resume template sources to derive the most successful resume formats. For my approach, I reference the key concept of these resume parsers, and then used NLP to gather keywords from the skills and experience sections of job descriptions. And then we match those keywords to the user skills database. The matching keywords would be included in the final resume. So the tools I chose for this project are Python for the scripting. We use Spacey, which is a Python library that's used for the natural language processing, using like tokenization, part of speech tagging, chunking, etc. And then we use JSON for the creation of the user skills database. This database would include information like their previous work experience, education, certifications, and soft and technical skills. And then we use docx to add the information to a Word document and format it. So as I mentioned before, I created a NoSQL database. We also want to reference the information for resume templates to select the best the best template on best practices and personal preference. The implementation of this data collection point would be in the future work. With Spacey, I collected keywords from a job description for skills matching, and the keywords that are missing from the job seeker's software technical skills are brought up to the user so they have a chance to append the new data to their database just in case it's like something they missed or failed to include. Over time, the frequency of these prompts would lessen as their database becomes more comprehensive. So as I mentioned in my problem statement, a lot of focus is paid to the recruiter instead of the job seeker. So I couldn't really find any projects that were similar to mine. So instead I focused this section on resume studies, which show that many resumes fail to include enough keywords and skills. And even if they do, only half of those are like relevant keywords. So an obvious issue and lacking. Another issue is that many resumes include too much fluff or buzzwords just to reach a respectable resume length. By matching these skills to job requirements directly, we can minimize these issues while ensuring resume relevance. So throughout the project, we found that most resumes don't match either the recruiter's criteria or the AI parser they use. This is mostly due to job seekers failing to include those relevant keywords and skills or adding unnecessary information and fluff. So the NLP techniques used in AI resume parsing can be employed similarly to help the job seeker with their resumes. I also found that NoSQL would be the best database option to store user data because of the non-relational nature, and it provides easier writing and reading for both users and the developer, me. So lastly, using templates or even tips from trusted resumes websites can ensure sound structure and visual appeal for the resume. To conclude, we introduced the idea, the issue of AI parsers being used to check skill relevance in resumes. We identified the key techniques to use in the project, from keyword identification and skills matching with NLP to resume formatting with docx. And then we demonstrated how an automated resume builder could be useful for job seekers. So in future work, I would put a lot of time into increasing the accuracy of the keyword identification to maintain data integrity, because there's still some weak points in that area. I'd also like to integrate my program with a resume checker like resumeworded.com to ensure that the final product will be approved by the AI parsers. I'd also integrate a trusted resume template website so the users can choose their own template instead of just being stuck with a single one. And then lastly, I'd create a user interface to increase usability. And it would also provide the chance to add a sort of tutorial for the new users to learn what data is required to start using the program. Here's my references. And are there any questions?
Yeah, that's a really cool project that you worked on, Joey. I did have a couple questions. This is a problem that I've thought about a lot, and so I'm really curious. I've done a couple very bad versions of this myself.
Yeah, I would
that
say
really
this
worked.
isn't my best version either, which is why I'd put a lot of attention into the future work. But it gave
Yeah,
me
I
like a
mean,
basic bone structure, you know?
yeah, I mean, it's a really difficult problem because it is, I mean, it's really hard to identify the keywords, right? You know, in the job postings, and then also, I mean, I imagine it's hard to sort of match those with skills, right? Like to have in synonyms or something like that.
Yeah.
Uh,
I mean, there's a lot of ways to do that. Like it kind of, I feel like the biggest failure with this kind of project is like how informed is the user, because they have to create their own database in the beginning. So depending on how good that database is or not will kind of gauge the success of the end result, you know?
right. Yeah, for sure. For sure. Yeah, that's super cool.
Thanks.
Joey, I just want to say good job, man. I know
Appreciate it.
this last 10 weeks has been rough on us.
Yep.
Seeing the progress that you made and actually seeing your project come together, I'm happy for you, man.
Appreciate it. Thank you.
Cool. All right. Well, if there's no more questions, we might end the meeting here.
All righty.
Good job, everyone. Yeah, thank you.
All right. Have a good night.
You too. Okay. Good night, everyone.
Interesting. When my group finished, we were sent back to the main room again.
Oh, so this group is finished? You could, you know what you can do if it doesn't kick back, just sign out and sign back in.
Yeah, just rejoin. All right, cool. Also,
Okay.
I think the recording's still going.
Okay, someone should turn it off.
Uh-oh, it's you and me.
I gather you're over, huh?
Yeah, we one of our presenters didn't show up, so we were pretty quick.
Okay, I just stopped recording then.
Oh, cool. You found it.